Points inside, on, or outside a circle. Method 1. To find whether a point is inside, on, or outside a circle, calculate the distance from the centre, 0, 0, to the point, and compare this distance with the radius. 3 cases arise. So here we see a circle, and the point is inside the circle. So this is for inside. Distance from the centre to the point is less than the radius, therefore the point is inside the circle. So the distance from the centre to the point is less than the radius, so the point must be inside the circle. Here we see a circle, and the point is on the circle. Distance from the centre to the point is equal to the radius. Therefore, the point is on the circle. So the distance from the centre to the point is equal to the radius. Therefore, the point is on the circle. And here we see a circle, and the point is outside. Distance from the centre to the point is greater than the radius. Therefore, the point is outside the circle. So here's the centre, here's the point, and this distance is greater than the radius. So the point must be outside. Method 2. The equation of a circle can be in the form of x squared plus y squared equals r squared. This is if the centre is 0, 0. X minus h to be squared plus y minus k to be squared equals r squared. Or x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. If the coordinates of a point satisfy the equation of a circle, then the point is on the circle. Otherwise, the point is either inside or outside the circle. By substituting the coordinates into the equation of the circle, one of the following situations can arise. So the left-hand side is less than the right-hand side, so the point is inside the circle. The left-hand side is equal to the right-hand side, the point is on the circle. The left-hand side is greater than the right-hand side, the point is outside the circle. And by LHS, left-hand side, we mean the left-hand side of the equal sign. And by RHS, right-hand side, we mean the right-hand side of the equal sign. So your circle is going to be in one of these formats. You take the point in question, you swap the x value for the x's, you swap the y value for the y's, and then you simplify. So for example here, you'd swap the x value for this x, so you'd square it, you'd swap the y value for this y, you'd square it, and you would see what your radius squared was. So if we have the left hand side less than the right hand side, the point is inside the circle. The left hand side equal to the right hand side, the point is on the circle. The left hand side greater than the right hand side, the point is outside the circle. Determine whether the points minus 3 minus 2, 5 minus 1, and minus 2, 1 are inside, on, or outside the circle x squared plus y squared minus 2x plus 8y minus 8 is equal to 0. So using method 2, here's our equation. So we're going to swap each of these x's for minus 3 with brackets, and each of these y's for minus 2 with brackets. And then we multiply out the left hand side, and we end up with minus 5. And minus 5 is less than 0, so the point minus 3 minus 2 is inside the circle. Next, we swap each of those x's for 5 with brackets, and each of the y's for minus 1 with brackets. We multiply out, and we end up with 0. And since 0 is what we had on the right hand side, we have 0 is equal to 0, so the point 5 minus 1 is on the circle. And for the last one, we swap each of those x's for minus 2 with brackets, swap each of those y's for 1 with brackets, and multiplying out, we end up with 9, which is greater than 0, so the point minus 2, 1 is outside the circle. Intersection of a line and a circle. To find the points where a line and a circle meet, the method of substitution between their equations is used. The method involves the following 3 steps. Step 1. Get x or y on its own from the equation of the line. Look carefully and select the variable letter that will make the working easier. Step 2. Substitute for this same variable, letter, into the equation of the circle and solve the resultant quadratic equation. Step 3. Substitute separately the values obtained in Step 2 into the linear equation in Step 1 to find the corresponding values of the other variable or letter. Note, if there is only one point of intersection between a line and a circle, then the line is a tangent to the circle. The equation of a circle is x squared plus y squared plus 4x minus 2y minus 5 is equal to 0. The line x minus 2y minus 1 is equal to 0 intersects the circle at the points P and Q. Find the coordinates of P and the coordinates of Q. Step 1. Get x or y on its own from the line. So our line is x minus 2y minus 1 is equal to 0. So solving for x, getting x on its own, we have x equals to 2y plus 1. Step 2. Substitute 2y plus 1 for x into the equation of the circle. So we swap that x for 2y plus 1 with brackets, make sure it's squared, bring down the y squared, bring down the plus 4, swap that x for 2y plus 1 again with brackets, bring down the minus 2y, the minus 5 and equals 0. So we've literally just put 2y plus 1 for x. Next we multiply out 2y plus 1 squared. Well, 2y plus 1 squared is the same thing as 2y plus 1 multiplied by 2y plus 1, which gives us 4y squared plus 4y plus 1. Next, bring down the y squared. 4 by 2y is 8y, 4 by 1 is 4. Bring down the minus 2y, bring down the minus 5, the equals and 0. Simplifying, 4y squared plus y squared is 5y squared. 4y plus 8y minus 2y is plus 10y. And 1 plus 4 minus 5 is 0. So we have 5y squared plus 10y is equal to 0. Simplify by dividing both sides by 5. So we have y squared plus 2y is equal to 0. Factorize using HCF, highest common factor. So we have y times y plus 2 is equal to 0. So y must be equal to 0 and y must be equal to minus 2. So we have two y values. Now we need to find our two x values. Step 3. Substitute separately y equals 0 and y equals minus 2 into the equation of the line in step 1 to find the x coordinates. So we found y equal to 0. So the equation of the line we rearranged to get the x on its own. So we had x equals 2y plus 1. So we swapped that y for a set of brackets, put 0 into it. 2 times 0 plus 1 is 1, so x is equal to 1. So the point is 1, 0. We do the same with y is equal to 2. So we have x equals 2y plus 1, that's the equation of the line. So up the y for a set of brackets, put minus 2 into it. 2 times minus 2 plus 1 is minus 3. So x equal to minus 3, so the point is minus 3 minus 2. Thus the coordinates of the points of intersection are P minus 3 minus 2 and Q 1 0. The diagram on the right illustrates the situation. So here's the x-axis, here's the y-axis, here's our circle. It has a centre minus 2, 1. Here's the line, x minus 2y minus 1 is equal to 0. And here are the 2 points where it intersects, P minus 3 minus 2 and Q 1 0. L, 3x minus y plus 8 is equal to 0 is a line. And C, x squared plus y squared minus 4x minus 8y plus 10 is equal to 0 is a circle. Verify that L is a tangent to C and find the point of contact. As we need the point of contact, we use an algebraic approach. Step 1, get x or y on its own from the line. So we have 3x minus y plus 8 is equal to 0. So it's easier to get the y on its own because if we get the x on its own, we're going to have fractions and we want to avoid having fractions. So rearranging, we get minus y equals minus 3x plus 8. And remember, we want y, not minus y. So changing the sign to get y equals 3x plus 8. So now y is on its own. So y is equal to 3x plus 8. So next we're going to substitute 3x plus 8 for y into the equation of the circle. So the equation of the circle is x squared plus y squared minus 4x minus 8y plus 10 is equal to 0. So we're going to swap each of those y's for a set of brackets and put 3x plus 8 inside the brackets. So we bring down the x squared. The plus y squared becomes plus bracket 3x plus 8 to be squared. The brackets are very, very important. Bring down the minus 4x, bring down the minus 8, swap that y for a set of brackets and 3x plus 8, bring down the plus 10 and equals 0. Then we multiply out the brackets, but first of all we bring down the x squared. Then 3x plus 8 to be squared is the same thing as 3x plus 8 multiplied by 3x plus 8, and that gives us 9x squared plus 48x plus 64. We bring down the minus 4x, minus 8 by 3x is minus 24x, minus 8 by 8 is minus 64, bring down the plus 10 equal to 0. Then we simplify. So x squared plus 9 squared gives us 10 squared, 48x minus 4x minus 24x gives us 20x, and 64 minus 64 plus 10 gives us 10. So 10x squared plus 20x plus 10 is equal to 0. We divide across by 10. We get x squared plus 2x plus 1 is equal to 0. We factorize, we get x plus 1 times x plus 1 is equal to 0. So if x plus 1 is equal to 0, then x is equal to minus 1, and x is equal to minus 1 again. So we see that we have the same x value. So we're going to sub that x value back into the line equation, the linear equation, to find the y value. So we substitute x equals minus 1 into the equation of the line in step 1 to find the y coordinate. So x is equal to minus 1. The line is y equals 3x plus 8. We swap that x for a set of brackets, put minus 1 into the brackets. 3 by minus 1 is minus 3. Bring down the plus 8. Minus 3 plus 8 is 5. So y is equal to 5. So the point of contact is minus 1 comma 5. Since there is only one point of contact, minus 1 comma 5, between L, the line, and C, the circle, the line L is a tangent to the circle C. So this is what it looks like. Here's our x-axis, here's our y-axis, here's our circle C, here's the line L, and here's the one and only point of contact, minus 1 comma 5, which makes this line a tangent to the circle. Note, to show that a given line is a tangent to a circle, it is sufficient to show that the perpendicular distance from the centre of the circle to the line is equal to the radius. However, to find the point of contact, an algebraic method as shown above is required. So using the perpendicular distance formula is a much shorter, quicker method, but it does not give us the point of contact. And in other videos you will see the perpendicular distance method.